Okay, in previous times, recent enough times, I've done two different videos. One was about how maps, the existence of maps and how we use them, can only happen if the Earth is flat, um, and about how the globe itself and the surface of a globe or a sphere is always three-dimensional, not two-dimensional. Now I'll put those links to those videos in the description of this video. This video, I'm going to marry the two things together because they're both connected, as I said in the video about the three dimensions of a sphere. This is a map of Africa, obviously. Ignore the background. Pay attention to this part down here, right? I'm going to be coming back to this a little bit later. But first of all, I must go through a couple of things. Okay, so spherical triangle, right? You'll understand in the close future why I'm going into this. A spherical triangle. A spherical triangle is a figure formed on a sphere's surface by three intersecting great circle arcs. Unlike planar triangles, the sum of a spherical triangle's three interior angles is always greater than 180 degrees. The difference between this sum and 180 degrees is known as the spherical excess, used to calculate the triangle's area, right? So now they call them a spherical triangles. They're not, as they even just said. They're the intersection of three circles of equal radius to the sphere. So that's what they actually are, right? A claimed spherical triangle. It's not a triangle. It's not trigonometry. It's circleometry. That's what it is. That's the more correct way to describe it. Let's just be honest about it. Definition: bounded by three great circles with the same radius as the sphere. Sides and angles. Both sides and angles are measured as angles. Sides are arc lengths representing angles from the center of a sphere, right? Because it's from the center that these things are, using actual trigonometry from the center of a sphere is how these things are determined. Spherical excess, sum of angles 180 degrees. A triangle can even have three 90-degree angles, totaling 270 degrees, which is why they're not a triangle, right? Because you can't have a triangle will never have more than 180 internal, a sum of 180 internal degrees. You have, this is for the spherical excess. I've shown this in the past, or a variation of it in the past in my other videos, just like how spherical excess is determined, right? Basically, if your circleometry triangle, I can't even call it a triangle, has, let's say, 195 degrees, then you have 15 degrees of spherical excess. That's the best way to describe that. Now, here is, right, a claimed, right, spherical triangle, which is circleometry. As you can see, right, if you add those three up, they're going to come to more than 180 degrees. How they actually even measure them is via tangents, because they can't measure them with the curves. So the tangents, so they'll have 6 tangents here, and they'll measure the angle between the tangents. That's how they actually will do it geometrically. But it's three-dimensional, right? A sphere is three-dimensional, and a spherical claimed triangle is three-dimensional also. So, why is a spherical triangle three-dimensional? Now, a spherical triangle is considered three-dimensional because it is formed on the surface of a 3D sphere. Formed on the surface of a 3D sphere, with its sides defined by great circles, the intersection of a plane passing through the sphere's centre and the surface. Unlike flat 2D triangles, these sides are arcs, and the figure possesses depth relative to a flat plane, right? So I'm just going to go down to more, right? Curved surface definition. It consists of 3 vertices on a 3D sphere surface connected by arcs of great circles. Diagonal angle, or angles. The angles at the vertices are not just flat angles, but the diagonal angle between the planes of the sides. Angular sides, the sides themselves are measured by the angle they subtend at the center of the sphere. Three-dimensionality, a sphere, and consequently a spherical triangle on its surface is a 3D shape defined by its curvature. Now, remember that, a sphere and consequently a spherical triangle on its surface, right, is a 3D shape defined by its curvature. While the surface itself is a 2D manifold, right? But now that's straight away after contradicting two different statements up here. Construction and properties of spherical triangles, such as the sum of angles exceeding 180 degrees or pi radians, are fundamentally dependent on the three-dimensional space. So they're trying to claim that the surface of the sphere is two-dimensional, while they're saying here a sphere and consequently a spherical triangle on its surface is a 3D shape defined by its curvature, because the curvature is three-dimensional. An up here curved surface definition, it consists of three vertices on a 3D sphere's surface connected by arcs of great circles. Right, 3D sphere surface. It is formed on the surface of a 3D sphere with its right. So a spherical triangle, right, which is, I'll just go back. They're claiming this, right, is three-dimensional, but the surface it's on is not three-dimensional. That's what they're trying to claim there. Now that's complete and utter rubbish, right? Because they contradict themselves in this, because they're claiming that twice that the surface is three-dimensional and then claiming that the surface is two-dimensional. That's what they're literally doing. Because you can't have a spherical triangle, right, be three-dimensional, and the surface of a sphere be two-dimensional, as that is part of the surface, right? The surface of a sphere is not two-dimensional, it is three-dimensional, as I have proven in the past, right? But I'll just move on to, I asked a different question. Can a spherical triangle lay on a 2D surface? So if they're claiming, right, so while the surface itself is a 2D manifold, right, that's what they're referring to, the surface of a sphere, right? Can a spherical triangle lay on a 2D surface? No, a spherical triangle cannot lay flat on a 2D surface, a Euclidean plane, without distortions, as it is a fundamental object of curved geometry. A spherical triangle is formed by three arcs of great circles, this closest equivalent to a straight line on a sphere, right? In other words, it's not a straight line, it's a curve. Because the surface of a sphere is curved and a 2D plane is flat, they possess different intrinsic geometries, right? Key differences include angle sum. The interior angles of a spherical triangle always sum to more than 180 degrees, pi radians, whereas plane triangles always sum exactly to 180 degrees. That's because one of them are a triangle and the other one is not a triangle. One of them is actually a triangle. Curvature. Spherical triangles have positive curvature. A plane has zero curvature. Distortion. Attempting to flatten a spherical triangle onto a 2D surface is impossible without altering its side lengths or angles. Well, you're going to alter both, more or less, which is why map projections are always distorted, right? When they can approximate a 2D surface, if a spherical triangle is incredibly small relative to the size of the sphere, it behaves nearly like a planar triangle, as the curvature is negligible locally. However, geometrically, it is still a curved figure, not a truly flat one, right? So this is just total and utter nonsense. This is like little caveats that you have to put in there. No, it is never going to be two-dimensional. It is never going to lie flat on a plane. A claimed spherical triangle will always be three-dimensional because the surface it's on is three-dimensional. At all times, it will never be on a plane. That will never be the case. So, as you just here, just to show from this Wolfram math word, you can see here, right, this is right a spherical triangle formed from the center, right, because it's formed using actual triangles, using actual trigonometry. Right, right angles and that, and you can see here, right, that it is absolutely just like the sphere it's on. Although this is just like the sphere it's on. Although this has edges, it's not a perfect sphere. It's spherical in shape, but it's definitely three-dimensional. You can see that it is three-dimensional, and a sphere is three-dimensional. There's no if buts, no maybes about that. That's what it is, right? So a claimed spherical triangle, right, which is not trigonometry, it's circlometry, is three-dimensional. It's the surface it sits on is three-dimensional. That's the surface of a sphere. They try to claim that the surface of a sphere is two-dimensional because they need to claim that to hijack things like the latitude and longitude grid and the XY grid. They need to claim that, right? Because the latitude and longitude grid and the Cartesian grid are used, one is a polar, which is the latitude and longitude grid, and the Cartesian grid, which is an XY grid, right, are used in reality, right, when measuring and for maps and for navigation and different things like that. Right, so they need to claim the surface of a sphere is two-dimensional because they need to hijack those things in reality. When x and y is 2 dimensions, latitude and longitude is 2 dimensions. There's no third dimension unless you add the z to the x and y. Then there you have the third dimension, right? But the x and y itself is only 2, and the latitude and longitude is only 2. That's why polar and Cartesian grids or XY grids work together perfectly all the time. You can translate and transform the coordinates over. You can always do that. So, but you can't place any of them on the surface of a sphere and have them work. It do not fit because the surface of a sphere, right, is three-dimensional, as is proven by a spherical claimed triangle, right? So that leads us to the next place. I'm just going to minimize this a sec, which is here, right? So here is a sphere, right? 3D calculator, right? So it is a sphere. Here, a sphere, AB. I'll remove it, place it back in again, right? That is a sphere. Here is a triangle. That's what this is, this polygon, right? So I just remove it, right? Triangle, and I have 3 angles in there. When you add these angles up, they will come to 180 degrees, right? That's what they'll be. You can add them up, 83.56, 42.94, and 53.5. Add those together, you'll get 180. So this is an actual triangle on the surface of a sphere. But it's actually not on the surface, it's tangent to the sphere. That's what it is. So it's not on the surface, it's tangent to the sphere. If you place this onto the surface of that sphere, what's going to happen is these straight lines here are going to start bowing out the way, right? And increasing in length. And these angles are going to increase in length. Kind of like, where are we? Right, just like this. That's what's going to happen, right? If you try to place that triangle onto the sphere, it's going to end up looking something like this. That's what's going to happen. So there's an increase in the length of the line. There is an increase in the internal angles. And that gives an overall increase in the area. Why does that happen? Simple. Because the surface of a sphere is three-dimensional, whereas a triangle is two-dimensional. So when you try to place that triangle, that's two-dimensional shape, onto a three-dimensional surface, there will be distortions, as is proven by claimed spherical triangles. So there's no way around that. It is distorting, right? It's distorting it because the surface it's going onto is not two-dimensional, right? That is just the truth. It's just the facts, as is proven by claimed spherical triangles, circulometry. So, where am I going with this? Right, this is where I'm going. So, if I take this map and I draw a triangle on it, right? I've drawn a triangle here from Rabat, which is the capital of Morocco, to Cairo, which is the capital of Egypt, and down to Maputo, which is the capital of Zimbabwe, right, as far as I can see. And on that triangle, you can see those lines are straight. Now, in the background, right, of this map of Africa, you can see they have what appears to be the implication of it being on a sphere, right? Now, these lines are straight. This is not a claimed spherical triangle, incorrectly named spherical triangle. This is an actual triangle, with its internal angles will match 180 degrees. If we come down here, we have different elements on this map. We have these brown lines are international boundary. Red line is road. Blue line is river. The black star is national capital. The dot is city or town. And then we have here a scale from 0 to 1,000 miles. That's 2 inches scale. So for every 1 inch is 500 miles, every 2 inches is 1,000 miles, right? So that means that from Maputo, right, 2 inches up on this map is 1,000 miles. Now, that's 1,000 straight, linear, horizontal miles. That's what's being employed, right? Another 2 inches up is another 1,000, another 2 inches up is another 1,000, and so on. Another 2 inches is another 1,000, right? All the way around, right? So there is no if, buts, or maybes that the scale on this map is matching, right? This scale here is matching a flat 2D plane, right? That's now obviously Africa is going to be two-dimensional because it's going to have elevation changes, but it's overall it's not going to be totally two-dimensional because it'll have elevation changes, but its overall surface can only be described as flat, right? And the reason this proves that Africa and the rest of the world, and of course all maps prove it's flat, that the Earth is flat and can only be described correctly in that way, is because these are actual distances that you can travel, right? And within this area here, right, or within these 3 straight lines, the area that exists there, right, will match reality. If this, right, if Africa was on a globe Earth, on a sphere, then what would happen is this would be what the triangle would look like. There would be more than 180 degrees, and you would have an excess of area in here that could not be placed onto the map, right? Because you couldn't straighten out these lines, which would shorten them, and then change also these degrees of angle, right, to 180, as a total of 180. You could not do that without losing area, right? There's an area here that will be lost. Now, if this is reality, if the Earth really was a sphere and this was reality, then there is no denying it that on this map there has to be some ratio to add back in that missing area, right, within those 3 straight lines and the missing distance along the straight lines themselves. Because in reality, if the reality was that we were living on a sphere, then this straight line here, right, between Maputo and Cairo has to be greater in length than is shown on the map. Because it's not going to be straight, it's going to be curved, which means it'll be a longer line than this. The same for this one between Cairo and Rabat, and the same for the one between Rabat and Maputo. They will all be longer, they will all bow out the way, which means there will be greater area in here. So there should be 2 extra things here, 2 extras here on this map, and on every map, regardless of the size of the map, there should be 2 ratios, one for adding in the extra area and one for giving extra length to the lines. There would have to be, if this really was this country, or this continent of Africa, the continent of Africa was really existing on a sphere Earth, then there'd be no way that this map here would be usable. It'd be impossible for it to be usable without having those ratios. Because if a plane is flying from, let's say, 1 second now, I just get, give me a line, right? So I'm going to change the color of the line to, let's see, something. I'll change it that color, it can be seen. So if a plane is flying from Cairo, let's just say, to, right, in the direction of Abuja here, right, then if it's flying from here to here, like this, then this line is going to be longer than is shown on this map. Because if we were living on a globe, these 3 lines would be bowed out the way, the area in between here would be greater, and all 3 lines on the outside would be longer, and this purple line would be longer than is shown on the map. Now, I can absolutely guarantee you that there is no corrections on any flight charts, right, or any maps anywhere in history to add back in missing area and give extra length to lines. I can absolutely guarantee you that never existed and never will. Because in reality, someone flying from here to here, right, would fly this exact distance along this purple line. There would be no need to ever add in extra length to the line. There would be no need to add in extra area in between the blue lines, right? That is exactly what we're seeing here, is exactly reality. Now, this can't be reality if the Earth is a globe. It's impossible, because there is no way for these two-dimensional distances, right, and this area that's going to be calculated within 2 dimensions, there's no way for that to fit reality if Africa is on the surface of a sphere, because that will mean that it's on a 3-dimensional surface. Right? There's no way around it. None of these can work. Right? And there would have to be extra calculations here, extra ratios added into this section on the map, right, where 1,000 miles is 2 inches, right, flat, but then they'd have to have a second one where actually it's not going to be that 2 inches is actually going to be 1,200 miles or some nonsense like that. Right? In reality, it'll be 1,200 miles, not 1,000 miles. It would have to be like that. There'd be no way that you could draw triangles on a map and then use the area within those triangles or the straight line distances. It just cannot be done. If the Earth is a sphere, without those ratios, it can't be done. So if we're using maps all the time without those ratios, and we've been using them without those ratios consistently for God knows how long since the maps turned up, then that proves without a shadow of a doubt that the Earth is flat and there is no globe. End of story. There is no fighting this, there's no going against this. That's just the way it is. As is proven by their claimed, incorrectly called, spherical triangles, right, requiring a 3D surface of a sphere. End of story. There's no way out of it, no way around it. It's a done deal. Thanks for watching.